Not that you have a choice. But I appreciate the patience with the kind of the weights to get that right. Our first 4 examples here. Applying these rules. Let's go through the rules in order. The first rule on problem number 10, the first rule says clear the fractions, right? Or the first strategy, clear the fractions. But there aren't any. The next strategy says undo the parentheses using distributive property. Well, there aren't any parentheses either. Third strategy says gather like terms. There isn't any like terms on one side or the other. That is, there's not like an 8 plus 3 over here or 5x plus 2x over here. It's just there's an x term and a constant term. Here there's just a constant term. So our gathering like terms has been done. We're now down to this 4th step, which is getting all the constants on one side and the variables on the other. And so the variables are already on one side, notice. The variable in this case is x, and it's on this side, the left-hand side. So part of what's joined to it is this 3. And how 3 is joined to this is addition. So we undo that by subtraction. Except for if we subtract 3 from one side of the equal sign, we have to subtract 3 from the other side of the equal sign. And so that leaves us here with 5x on this side of the equal sign and 5 on this side of the equal sign. Next step is we want to get x all by itself. Well, what's not having x all by itself? Namely, the fact that there's this 5 multiplied by it. How do we undo multiplication? Division. So we divide this by 5. Except for if we divide this by 5, we divide this side by 5 as well. And what we're left with is x equals 5 over 5 is just 1. And then our last step is to check it out and see if it works. 5 times 1 is 5, plus 3 equals 8, and that ends up with a nice balanced equation. Problem 18. Pretty much the same type of problem as what's up above. There's no fractions. There's no parentheses. So we want to get, there's no like terms that are left uncombined. So our next step is to use addition and subtraction to get all the variables on one side and the constants on the other. Well, the variables already are on one side. The t is the variable, and it's already on this left-hand side. So now we just have to get all the constants on the other. That's just moving this 23. Well, we don't really call it moving the 23. What we do is we use the 4 rules. 23 is joined by addition. We get to subtract it to get rid of it. But if we subtract on this side, we subtract on this side as well. And that leaves us with 96t on the left-hand side and negative 288 on the right-hand side. The next step is at step 4 that talks about getting the coefficient, or step 5. Step 4, getting the coefficient of t to be 1, that is, making it 1t.
6.
That's step 6.
Yes.
Okay? Divide both sides by 96. And you're left with t equals
Negative 3.
-3. And we check and see if that works.
It does.
It does. Negative 288 plus 23 is negative 265. It works. Problem 22. Yes, question.
Okay, that's my check. But how do you know when the two positives don't make, you know,
How do I know when to do positive, when to do negative?
when do you know that you add those and didn't take them away?
Okay. Good question. Here's what I think the answer is, if I've got your question right. You want to know, okay, I've got this straight 23 here. The first thing you do is you're focusing on one side first. So I'm focusing on, my task is to get t all by itself. And the first step is to get additions and subtractions, to get the t's all over on one side and the numbers all the other. So I know the t's are already on this side, so I want the numbers over here. That's the first thing I know. The second thing I know then is how do I get this. What's wrong with the picture? In other words, if I want all my t's here and all my numbers here, what's wrong with this picture? There's this 23, right?
Yeah.
How do I get rid of a positive 23?
Yeah.
I subtract 23,
Yeah.
right? But if I subtract 23 here, I've got to subtract 23 here. So the way to keep straight whether you add or subtract is by... Sorry about that. The way you keep straight of whether you add or subtract is to focus on one side at a time, do what you need to one side to make it more like what you want, and then do the same thing to the other side. And hopefully after we've seen a lot of examples, that process starts making sense.
Yeah. What I'm getting at is a negative you add.
Yeah, so if this were minus 23 instead of plus 23, you'd have to add 23 to make it go away.
Yeah.
So you'd add 23 here and add 23 here. That's what you would do if it were negative 23 here.
Yeah, I get that.
Okay. Want to look at a couple more examples and see if it clarifies your question a little?
That might jump.
That makes sense?
What that might jump if you add before. That might good jump. Okay.
Okay. Let's do a couple more examples and see if the question kind of clears up
Yeah.
a little bit.